All right, so this is the next problem. It's very similar to the last problem. In this problem, you're going to be integrating, which is the critical skill. All of the problems require that you integrate, so if you know how to integrate, you should be good to go on most of the problems. As you saw in the last problem, there's going to be quite a few steps in this problem too. So again, we're given a function. I know that this is a derivative function because I see dh dt. That tells me this is a rate of change. It is the derivative of some other function. If I integrate this function, I will get back to the original function, which in this case is going to be the height function. So I need to integrate that function right there. And that's what I'm going to do. I'm going to integrate this function right here. And whenever you're integrating, remember you're always going to end it with d, in this case t. If it had been an x right here, that would have been a dx. That's how you do integration. You do integral sign, and then it's with respect to whatever your variable is. So dt in this case. So I'm going to integrate that function, and I'm going to use u substitution just like I did in the last video. So in this one, the inside function is this right here, 17.6x squared plus 1. Or t squared rather, 17.6 t squared plus 1. I'm going to say that's my u. U is 17.6 t squared plus 1. And just like in the last video, I'm going to take the derivative of that function. The derivative of 17.6 t squared plus 1. Remember from a few weeks ago, when you're taking the derivative, you take this and you bring it to the front, so it's going to be 2 times that, and then you subtract 1 from your exponent. So the derivative of that is going to be 35.2 t. And I'm going to have a dt right there. Okay, so that's the derivative. I took the derivative, I have du, I took the derivative of this whole function, which gave me 35.2t, then I have a dt right there. And what I want to do is I want to go back to my original function, and I want to see if I can rewrite everything in terms of u and du. In terms of u and du. And there's several ways to do this. Let me think about what the easiest way is real quick. Hold on one second. Yeah, I think the easiest way here, if I want to rewrite this in terms of u and du, I'm going to solve this for dt. I'm going to solve this for dt. And a lot of people always do that. They'll take whatever they get right here and they'll solve it for this, the dt in this case, or the dx if it was an x. So I'm going to do that. I'm going to divide this by 35.2t. I'm going to divide this by 35.2t. That cancels out, so I have du divided by 35.2t equals dt. Okay, so I have du divided by 35.2t equals dt. And now I can try to rewrite my function in terms of u and du. Let's see if I can do that. So I'm going to have the integral. Again, I'm looking at over this thing right here. I'm going to have the integral of, I have the 17.6t. There's nothing I do with that yet. Divided by the square root of, look right here, That's u. That's what we said u is equal to. So it's not the square root of this now, it's the square root of u. So I'm going to put u. And then I have this dt. Well, dt was this, which is in terms of du. So I'm going to replace this dt with what it's equal to. Du divided by 35.2 t. Okay. Now, we still don't have it all in terms of u and du because I still have a t. But what happens is this t cancels this t out. And 17.6 goes into 35.2 twice. So this actually simplifies to everything here is gone, which means there's a 1 remaining. So there's a 1 on the top, 1 divided by the square root of u times, and then we have du. Okay, we got 1 divided by the square root of u, and du. And, oh, yeah, don't forget about, I almost forgot that. We have a 2 on the bottom. We still got that 2 down there. So it's du divided by 2. That's really important. Don't forget that. Now everything's in terms of u and du. Everything is in terms of u and du. And that's what you want to do with u substitution. You want to take your original thing and using what you call the u and what you figure the du is equal to, you want to rewrite everything in terms of u and du. And that's what I did. Now let's look at this part right here. Du divided by 2. That's actually, I'm going to rewrite that. That's going to be, we still have 1 divided by square root of u. But if I divide something by 2, it's the same as multiplying by 1/2. So that's 1/2 du. So again, this stuff right here, du divided by 2, du divided by 2 is equal to 1/2 times du. Because if you divide something by 2, it's the same as multiplying it by 1/2. And when you're taking integrals, if you ever have a number, you can always move it out to the front. So I'm going to do that. I'm going to have 1/2 integral 1 divided by square root of u, du. And now I can integrate this because I know how to integrate that. 1 divided by the square root of u, I look at that and I know I can use the power property to integrate that. That's why we do u substitution. We're going from something I don't know how to integrate, and then by replacing everything with u and du, I'm getting to something I do know how to integrate. So I'm going to integrate this thing right here. And let me go ahead and do that. I'm going to have 1/2. That's still out front. And then I'm going to be integrating 1 divided by u. If I take the square root of u, that's the same as raising it to the power of 1/2. And I got du. And then I'm going to rewrite that, 1/2, the integral, this u to the 1/2, I can actually bring it to the top. Okay, I can actually bring that to the top. And when I do that, when I bring it to the top, that 1/2 is going to become negative. So it's going to be u to the negative 1/2 du. Okay, now the reason I did that is because now I can use the power property. I have an exponent brought to a power. I can use the power property now to integrate that. And that's what I'm going to do right now. So I'm going to drop that 1/2 down in the front. And I'm going to use the power property. The power property, again, when you're integrating, you're going to add 1 to the exponent, and then you're going to divide by the new exponent. That's the power property. Add 1 to the exponent, divide that by your new exponent. So I'm going to add 1 to the 1/2. So I'm going to go plus 1. Negative 1/2 plus 1 is positive 1/2. So that's going to be u to the 1/2, okay? Because that's what you get. Negative 1/2 plus 1 is positive 1/2. And then I'm going to divide by my new exponent, which is positive 1/2. And when you do this, when you divide by a fraction, you're actually multiplying by this fraction flipped. Well, if I flip this fraction, 1/2 flipped is just 2. So this is equivalent to 1/2. I just drop this 1/2 down. Then I'm going to flip this fraction times, if I flip it, it's now a 2, times u to the 1/2. And if I, let's see, if I multiply these together, 2 times 1/2 is 1. So these cancel out, and I'm left with u to the 1/2. And u to the 1/2 is just the square root of u. Okay, so it's the square root of u. And finally, I can substitute back in my u. And if you go back to the very top of the problem, we said that u was 17.6 t squared plus 1. So it's not the square root of u, it's the square root of 17.6 t squared plus 1 plus c. Because remember, when you're doing these integrals, there's always a plus c out here. It's just a number. It can be any number. So we put a c there because that can actually be any number. And that's going to be your, it's not quite your height function yet, but it will be here in a second. We're going to figure out the rest of it. So this is going to be equal to the height, because that's the function we're trying to find, is the height function. But we're not quite done yet, because this is not a specific function, because we have the c at the end. That's a general function. I could put any number into the c. I want to know what is this c specifically, so it meets these criteria, because they actually give you some more information. I'm going to erase this part right here so we can see the rest of the problem. Right there, it says the seedlings are 8 inches tall when planted. Right there, when planted. When they're planted, the time is 0. So t is equal to 0, and when t is equal to 0, h is equal to 8. So I'm going to put that information in here. T, when the t is equal to 0, then the height is equal to 8. And now I'm going to see if I can solve for this c right here. And I can. 0 squared is 0. 0 times 17.6 is 0. So this whole thing right here is just 0. This is the square root of 1, because that's just a 0. And the square root of 1 is 1. So this whole thing right here, is equal to 1. Plus c equals 8. And now I'm going to solve for the c. I'm just going to subtract 1 from both sides, which means that 7 equals c. So we actually figured out what the c is right here. It's 7. And now I can plug it in. So the height, I'm rewriting this, height equals this, the square root of 17.6 t squared plus 1. But now it's not plus c, it's plus 7. Plus 7. And that's my specific function right there. That's my specific height function right there. And for that, that's the answer that goes right here. That's the answer that goes right there. That is your height function. Now we're going to use that function to solve the next one, which is how tall are the shrubs when they are sold? Well, let's see. When are they sold? An evergreen nursery usually sells a type of shrub after 5 years of growth. Growth rate of 5 years is approximated by, okay, so they're selling them at 5 years, which means in my height function, I put a 5 into that. And then I figure out what that's equal to. So to solve that second part, it's going to be 17.6, 5 squared plus 1 plus 7. Put that into your calculator. That right there. And that will give you this answer right there. And that's how you do this one. And that's the critical skill in all the problems you sent me. You have to know how to integrate, because all of the problems you have to integrate. And this is how you do it. So I'm going to end the video here, and I'll send you other videos